My point is, when you look at this question and they tell you a straight line has a gradient m and passes through this points, they didn't tell you to find the equation of that line, but you can tell because it's 7 marks, it's going to be a lot of different components. Like you can already expect, it's going to be a lot of different components that are mixed together at the end to sort of formulate your overall solution. It's going to be much easier to do that if you have all the individual parts assembled. When I say assembled, it means without needing to be told, you find the equation of the straight line then. So do you follow why we would find the equation of the straight line first here? And then without further ado, you'd realize if you want to find the equation of the straight line, you're not trying to find the actual literal, numbers that represents the full equation because you don't have the number for the gradient. My point is, you can at least find something that represents the equation of this straight line. And you can also expect where this question's headed. They're expecting you to use something that represents the equation of that straight line, do something like that to overall find what m is going to be, etc. So without further ado, you'd find the equation of the straight line over here, or something that represents it, because it's going to help. And as we realize, a straight line, every single straight line ever, yes or no? Every single straight line ever has a very easy formula to use, which is y minus y1 equals to m bracket x minus x1. True or false? Without needing to be told, you would use that equation for that straight line, which is y minus negative 2, because you know for a fact this point exists on that line, so y minus negative 2 equals to m bracket x minus 0, which is what we've written over here. And we simplify this into y is equal to mx minus 2. Next part, they say that this line over here, so mx minus 2 now, do you see why it's a lot easier to sort of piece this logic together? When instead of dealing with this first sentence over here, you now have something like at least tangible. Y is equal to mx minus 2. You've got something that represents the equation of that straight line over here. And they're telling you that it's a tangent to this curve, which this is where you'd realize they're testing you. Hey, can you tell that if this is my parabola, it's a different curve over here? This is a parabola, this is my line, but if there's going to be a relationship, they're telling me in this question over here, this parabola and this straight line have a tangent relationship. This is where I'd realize if I make this equal to this, that's what's happening over here, isn't it? If I were to make it equal to that, and then simplify into the quadratic scenario, it's a scenario where the discriminant exists, and the discriminant has to be equal to 0. Do you see what this really is? This might look like some long working over here, but do you see what they're really testing you on here? They're testing you on, hey, is this the parabola? Yes. Is this my straight line? Yes. If they're telling me it's a tangent relationship, it's testing me. Do I know to make these equal to each other to create a discriminant scenario where the discriminant is going to be equal to 0? Because that's what describes tangent equal to 0. Why am I doing this? Remember, because I need to find equations that involve m. I need to find some sort of relationship, some sort of algebra equation involving m that allows me to find what m is going to be. If I don't have a basic equation involving m, how can I find what m is going to be? And you're not confused by why we need to find m, isn't it? It's pretty obvious the question's asking us to find m, right? Like, it's very obvious you need to involve m somewhere. You got to find what m is actually equal to. So that's why we make this equal to this, because that's what describes the tangent equals to the... This line touches a curve at one point. That's what tangent means. Discriminant scenario over here. This is basics of algebra over here, because you look at this. Minus 2x minus mx. You know from the basics of discriminants, this is factorized to make a, b, and c very obvious. Then you just do the math. B squared minus 4 is equal to 0. You recognize the discriminant equals to 0 is what represents the tangent scenario for this, because this is only supposed to have one solution. One solution here implies what? It's tangent, right? Tangent is only one point of intersection. That's what it means. So then you just do the discriminant over here, plug these in, make sure you know the algebra on this. If you don't know how to do this in one take, there's nothing stopping you from writing negative 2 minus m squareds, writing out the long way and then translating over here. You should know how to do this off the top of your head, but if you don't, just write it out the long way, it's fine. Make sure you just use the correct algebra as my points. No calculation errors. Over here you can tell it can be simplified and then you create this. Now when you make the discriminant equals to 0, it's going to create two answers, isn't it? M is 4 or negative 8. They tell you, for each value of m, find the coordinates of the point where it touches the curve. For each of these m's. Doesn't that just mean there's two different scenarios then? It's basically the same thing as saying what? When m is equal to 4, when m is equal to 4, you're going to have what? You're trying to find the point of intersection. The actual point of intersection is represented using this equation here, isn't it? X squared plus minus 2 minus m times x. You can replace the m with 4 now to find the actual point of intersection, because you already know by now this is the equation that you would use to work out that point of intersection, which is what the question's asking. Are you following this so far? So of course it just makes sense. You've got two different scenarios for m. You substitute the scenario where m is equal to 4 into this intersection 1 to find the answer, which is 3. You only have one answer, x is 3. Well, that's not a coordinate. They're asking you the coordinates of the point. A coordinate is an x and a y value. When x is 3, what's y going to be? Well, you can use any one of these equations here, can't you? Let's just use this one. Y is equal to mx minus 2. Substitute the m with 4. Y is equal to 4x minus 2, which is 3 times 4 minus 2, which is 10. Negative 8 scenario, same thing. Replace the m over here, because this is the equation that represents how you would find the point of intersection. You know this, because it came from making these two equal to each other. You understand how you would read the algebra over here? It all represents something. You can tell, like, this is a storyline in real time. replacing the m, negative 2 minus m becomes negative 2 minus negative 8, which is negative 2 plus 8. You know how to do this. You can understand how the solution here is going to be x equals to negative 3, which you substitute into either this original parabola or mx minus 2. Mx minus 2 is probably much easier. M is negative 8, so negative 8 times x, negative 8 times 3, negative 3, 24 minus 2, which is 22. And that's where you get the 2 points of intersection, 3, 10, negative 3, 22. Remember, you need to do this full question, unassisted, beginning to end, without the solution in front of you before you move on. No bloopers. Because you're really trying to practice on how you set up the question over here, doing the algebra correctly, knowing what to do with these discriminant answers. That's the real practice over here. This is what's really going to improve your instinct.